Hello everyone. In this lecture, we are going to study the following differential equations. And in this case, from previous equation, we had two more terms here. This term. In physically, the Cu term, this term is a reaction term. Maybe it depends on the constant C, and sometimes suppose U is a number of some of density function. The maybe as time goes by, the number of density is decreasing or increasing, so that depends on the U. And then the B term, this one is called the drift term, in physically drift term. So the U depends on the external force, some sort of external force. Suppose the U is moving to suppose diffusion process, then some force from outside will also make effect on the U. So that is called the drift term, and then C is a reaction term. So when you study some mathematical modeling, then you can actually see the reaction and drift term in the systems. When you do mathematical modeling of the system, which affect by drifter term and the reaction, then you will end up with getting these equations. But I'm not going to talk about in detail, but you just realize that the B term and C term comes in the PDE very often. Okay, so what I'm going to, so we are interested in finding a solution of this equation. So, but we also use the heat equation we discussed in the previous lectures. Okay, so here what I'm going to do is I have some different function v xt, and I multiply some, we have u xt, and then I try to multiply. So exponential maybe kt plus I use L. So m x. Okay. So I will show you why I took kt plus mx. Okay. So and then you can differentiate this guy with respect to t. What do I get? You differentiate this with respect to t, then ut exponential kt plus mx plus u xt. Let me make short. Okay, u times, so you differentiate, have k times u e to the kt plus mx, right? So that is ut plus ku e to the kt plus mx. That's what I have. And then next, I'm going to differentiate with respect to x once. Then you can differentiate with respect to x. Then u x e to the kt plus mx plus, now you put u, and I'm going to differentiate this one with respect to x. X, they have m u e to the kt plus mx. So that implies Okay, so that is equal to u x mu e to the kt plus mx. Okay, so I'm going to differentiate one more with respect to x. Then I differentiate this with respect to x, u xx plus mu x e to the kt plus mx plus I'm going to differentiate the second respect to m. Then let's see, mu x plus m square u e to the kt plus mx. That's what I have here. And then I'm going to put together the u xx plus twice m ux plus m square u and then e to the kt plus mx. That's what I have. And I'm going to subtract this equation, subtract this one from this. Okay, so I will compute. Let's simplify this one. Vt minus v xx. Okay, let's compute this one. Then Vt, so Vt is this one. Let's see, I'm going to keep. Okay, then you got Ut plus Ku. Okay, and then minus U xx plus e to m ux plus m square u and the exponential kt plus mx. So that's what I have. Is it right? Okay, so then I have here ut minus u xx. Okay, and then I have plus 2m ux plus k plus m square k plus m square u and then okay, so here and then e to the kt plus mx. Okay, and then what was here okay, I'm going to put a square everywhere. So I put a square, and I'm going to erase here. Okay, and then I'm going to put a square over here. Then I should put a square everywhere. So I'm going to rewrite this part. Okay, let me rewrite. So then I have a plus minus a square u xx minus 2a square m ux plus minus a square m square u and then e to the kt exponential okay, exponential kt plus mx. Okay, and then we know that ut minus a square uxx, that is in here. So that's equation from 1. I'm going to put this equation 1. let me, here, this is equation number 1, equation 2, equation 3, equation 4. That's equation number 1. So I'm using, not here. Then I'm using equation 1. You replace ut minus a square uxx by this one. So that would be minus bux minus cu, and then plus fxt, and the remaining term. So I got ku minus 2a square m ux minus a square m square u, and the e to the kt plus mx. Okay, and then I'm going to take this one. So let's look at that part. See, this one with this derivative, I'm going to remove. So I'm going to take b minus 2a square m equals 0. So I'm going to take m equals minus b 2a square. That is my m. Okay. If I take this one to be m, that term becomes 0. Okay. So if I take m equals so if m equals 2a square here, b minus b, then this term becomes 0. And also I have in the remaining term the cu k, this one, I want this one to be 0. Okay, minus c plus k minus a square m square. So I want this one to be 0. So m is taken. So then I take k equals c plus a square m square. Okay, my m square is this, c plus a square m. I take b square and then 4a square. So if I take c equals 2 here, 2 here, b square. Okay, that's my k. If we take k to be this number, then all terms gone, so only remaining part is this, fxt or exponential kt plus mx. Okay, that's very important. Okay, finally, so this is important. Okay, so finally I have okay, therefore let me take this rewrite here. If we take, if m equals minus b divided by 2a square, and then k equals c plus 2b square, then we have v t equals a square v xx, and then have f xt exponential kt plus mx. Okay, that's one equation. And then I take v 0t. What do I get? v 0t, we have x 0t, this u 0t exponential kt, x equals 0, and then v lt becomes u lt exponential kt plus ml. Okay, and then v x0 equals also u x0 e to the L mx mx. Okay. So that is would be gt exponential kt and then ht exponential kt plus ml. This guy lx e to the mx. Okay, so this is what our equation. So here if I take let f tilde xt equals fxt and e to the kt plus mx. My g tilde t equals gt exponential kt, and then h tilde t equals ht e to the kt plus ml. L tilde x equals lx e to the mx. Okay, then this does the, if I take this one, so this is just what f tilde xt, this one the t, ooh, sorry. This is g tilde t, h tilde t, this is L tilde x. Okay, this guy is f tilde xt. So then this is exactly the same form in previous lecture. So this is you can, so we derive the equation we already know. Okay, so this is the system. So and then we can solve. Then we can find a solution vxt, okay, by method of lecture 11 or something, lecture 10 or 11, 10 or 11, okay, the previous lecture. So then we are done. Okay, then finally our solution, then u xt was v xt e to the minus kx minus m minus kt minus mx, because in here, so we put v equals u xt exponential kt plus mx. Then you can solve this one for u, then v xt minus e to the kt minus mx. That's what I have. Then this is a solution of original problem. Okay. So here, just you only need to do is change function. So you replace, you consider new function v xt equals u xt exponential kt plus mx. Okay, then you got the new equation for v. Then the equation here v is we already know in the previous lecture 10, I guess. So then finally you can find the uxt. Okay, so let me stop here.